In this video, we will explore linear regression, a statistical method that helps us describe and understand how two quantities are related. In many scientific experiments, we collect data sets that seem to follow a trend. As one quantity changes, another changes too. If that trend follows a straight line pattern, we say the two variables have a linear relationship. Linear regression helps us find the best fitting line to model that linear relationship. From that line, we can write a mathematical equation that shows how the two quantities are connected. We can then use this equation to make predictions. Depending on the context, linear regression can serve different purposes. Sometimes, we already know the two quantities should be related linearly, and we can use linear regression to determine the equation that models that relationship. Other times, we use linear regression to test if such a linear relationship exists. How can linear regression be used to analyze data? Select all that apply. Great, all these are correct. Linear regression helps us do all these things. Before we dive deeper into how to perform a linear regression, let's first define a few terms. In a regression, we study how one quantity changes in response to another. The variable that we change or control in an experiment is called the independent variable. The variable that responds to those changes is called the dependent variable. A good way to think about these variables is that the independent variable represents the cause and the dependent variable the effect. The changes in the independent variable cause the changes in the dependent variable. In an experiment investigating how the number of hours students sleep affects their cognitive reaction time, which is the independent variable? The correct answer is hours slept. It's the independent variable because it's the factor that is intentionally changed to see how it influences the reaction time, which is the dependent variable. Now, let's try another example. In an experiment where researchers investigate how the number of cigarettes someone smokes in a week affects their lung capacity, which is the dependent variable? The correct answer is lung capacity. The number of cigarettes smoked per week is what the researchers vary as the influencing factor, so it's the independent variable. Lung capacity is the dependent variable since it changes in response to the number of cigarettes smoked in a week. Now that we've got a good grasp on the variables, let's talk about the mathematical equation that we use to model their relationship. The general equation for a linear relationship is y equals mx plus b. Here, y represents the dependent variable and x the independent variable. When plotting the data for linear regression analysis, we place the independent variable on the x-axis and the dependent variable on the y-axis. M is the slope of the line. It tells us the general direction of the relationship. A positive slope indicates a positive association, meaning that as x increases, y increases too. On the contrary, a negative slope suggests a negative association. As x goes up, y goes down. Below is a data set showing the number of hours students sleep and their cognitive reaction time. Which variable should be plotted on the x-axis? Which one on the y-axis? As we discussed before, hours slept is the independent variable, so when plotting the data, it goes on the x-axis, while the cognitive reaction time goes on the y-axis. Based on this plot, predict the sign of the slope for this linear equation. This data would have a negative slope. As the independent variable, hours of sleep, increases, the dependent variable, reaction time, decreases. The last term in the y equals mx plus b equation is b, the y-intercept. This is the value of y when x is 0. Let's say we can use the equation y equals negative 20x plus 460 to describe the relationship between how many hours students sleep per night, x, and their cognitive reaction time, y. Which value in this equation represents the y-intercept, and what does that intercept mean in this context? In this equation, the y-intercept is 460 when x equals 0, y equals 460. It means that when students do not sleep at all, their cognitive reaction time would be 460 milliseconds. Before we move on, a quick note about units. When working with experimental results, we must include units. Numbers without units have no meaning. Therefore, when reporting our linear regression equation, it is important to include the units. Select the correct equation that describes the relationship between how many hours students sleep per night in hours and their cognitive reaction time in milliseconds. In this example, the unit of the slope is milliseconds per hour, and the unit of the y-intercept is milliseconds. As we discussed earlier, sometimes we do not know if the two variables really follow a linear relationship, so in the last part of this video, we will introduce a tool that helps us evaluate how well the linear equation fits the data. This tool is the coefficient of determination, or commonly known as the R-squared value. R-squared tells us how well our linear model fits the data. In other words, how much of the variation in the dependent variable, y, can be explained by the independent variable x. R-squared values range from 0 to 1. The closer the r-squared is to 1, the better the line fits the data, meaning most of the variation in y is explained by x. The closer the r-squared value is to 0, the weaker the linear fit is, meaning the line does not explain much about the relationship between the two variables. Which dataset would have an r-squared value closest to 1? The dataset with the highest r-squared value would be the one about enzyme reaction rate, as the data points tightly cluster around the line, meaning the linear model fits the data more closely. Indeed, if you extract the r-squared value for each of the plot, the middle one has the closest value to 1. It is important to note that even if two variables have a negative relationship, as in this example, the r-squared value is not affected by the slope. It only measures how tightly the data points cluster around the line. This concludes our introduction on linear regression. In a separate video, we will go over how to perform linear regressions using a spreadsheet software. Thank you for watching.